Hello, this is Susan Poss. We're working still in section 5.2. This is the second video, and this one's called the power of a product rule. Let me see if I can tell you where those words are coming from. This is a product in here. We're multiplying these two quantities together, and you can see that they each contain an exponent, and then outside the parentheses is another exponent. So there is a product going on inside the parentheses and then raising that product to a power. So it's called the power of a product rule. So here's what it tells you to do. Basically what you're going to do is to take the exponent on the outside of the parentheses and use it as a multiplier of each exponent on the inside of the parentheses. So it's kind of just an extension of what we just did. We had something raised to a power on the inside of the parentheses and then another exponent on the outside of the parentheses, and we multiplied those two exponents together. So this is just extending that. What if you've got more than one base inside the parentheses? What if you have a product of several bases? And this is what we're going to do. So I have several examples here for us to work together. All right, so this first one, 5x is inside the parentheses raised to the power 2 outside the parentheses. So I hope that you see inside here we have a product. We have 5 times x. And you can see that I have rewritten that product, making sure that we don't forget that there are exponents of 1 on both the 5 and on the x. So now you're going to see me take this 2 on the outside of the parentheses and use it as a multiplier of each exponent on the inside of the parentheses. All right, so it's going to look like this. I'll go ahead and write it all down so you can see where everything is coming from. So this becomes 5 to the second times x to the second, and then of course this numeric part, 5 squared, I need to go ahead and finish that out, do the math, and so it becomes 25x squared. All right, same thing on the next one. You can see that I've written it so that you can clearly see the exponents of 1, and now you're going to see me multiply this 3 on the outside, the exponent on the outside, by the exponent on the inside. So this is going to become x to the 1 times 3 times y to the 1 times 3, or just x to the third times y to the third. All right, so this next one gets a little bit murky. I've left some of these worked out. I'm not going to work them all. I thought you might want to freeze the video and just look at them, study them on your own. So here, be careful with this one. This 1/4 does have an exponent of 1 right there, and you can see I've written it over here as I've written the example a little bit larger for you to see. So again, I'm going to go in here and I'm going to take this 3, multiply it by that exponent 1, 3 by that exponent 2, multiply 3 by that exponent 1. So let's see how this works out. So this is going to become 1/4 to, then I'm going to go ahead and write this and sort of skip a step because I don't have a lot of space here. So 1 times 3 is 3. This is going to be x to the 2 times 3 is 6. And this is going to be y to the 1 times 3 is 3. So part of it is done, but the arithmetic part right here needs a little bit of my attention. You can do this on the calculator, or you can just go off to the side and use that 1/4 as a multiplier 3 times. And I'm just multiplying across the top and across the bottom. I think that's 64, is that right? Yes, that's 64. So the final result would look like this. This numeric part would become 1 over 64 times x to the 6th times y to the 3rd. All right, so let me look at these last two and see if I think I need to say anything to you. Looks like this one didn't quite get finished, so let me see if I can finish this out. The -3 raised to the 4th power hang on, negative 3 times negative 3 times negative 3 times negative 3 is positive 81. So this works out to be 81 on the numeric part. This is a to the 12th, b to the 16th, and c to the 4th. So I didn't work every step on that, but I hope that was enough to get you started. And on this last one, you can just see me taking the exponent on the outside, multiplying each exponent on the inside by that. And the only funny wrinkle on this one is that this y to the negative 12th needs to be shifted down and become y to the positive 12th in the denominator. So that's a good place to stop with the power of a product rule, and you can see on the next one here we're coming up with the power of a quotient rule.